Today, let's look at hypothesis testing with two proportions. So here are the two main formulas. The first one is to calculate the z value, and the second one to calculate the total sample proportion. Now I'm going to add two more to these, which is first the first sample proportion, which is equal to x1 over n1, and then the second sample proportion, which is x2 over n2. So let's bear these in mind while we do the next exercise. The exercise reads, two samples of executives, 120 in finance and 180 in marketing, are polled for their views, which can be either agree or disagree, on the question, will Brexit be good for business? 54 finance executives agree, and 63 marketing executives agree. Conduct a suitable test of proportion at the 10% level to see if there's evidence of a difference of opinion between the two sets of executives. Okay. The first thing to do, as always with hypothesis testing, is to state the null and alternative hypothesis testing. The null and alternative hypotheses. So in this case, again, it's going to be between two proportions. Now the way this question is phrased, it's asking us whether there's evidence of a difference of opinion. So this means that the null hypothesis is that there's no difference. So in other words, the first proportion is equal to the second proportion. And then the alternative hypothesis is that there is evidence of a difference of opinion. So difference of opinion. So the alternative is that the first proportion is different to the second proportion. Now, given this information, what do you think? Is this going to be a one-tailed test or a two-tailed test? Now, this is indeed going to be a two-tailed test. And the reason is because the alternative hypothesis says it's different. So it can either be higher or lower. We don't know. So there's two sides to this. Okay. Then it says that the confidence level or the level is 10%. So this means that the area that isn't shaded is 0.9 or 90%. Then in order to find out the significance level on each side, because this is a two-tailed test, we need to take the level, so 10%, and divide it by 2. So the significance level, in this case, is 10% divided by 2, so 5%. And same on the other side. Okay, this can also be written as 0.05, okay? Next thing to do is to find the critical value. This is the value at which the shaded regions start, okay? Now in order to do this, we need to look at the Z table, and we need to find 0.05. So here is a bit of a tricky situation because as you can see, there's no 0.05. There's 0.0505 and 0.0495. So we're trying to find the one that's in between these two. So we still look horizontally, but we also look vertically on both values. So the horizontal value is 1.6. And then if we look vertically, we have 0.04 and 0.05. Now what we want to do is take both values, sum them up, and then divide them by 2. And this is going to give us the middle point, okay? Now this should give you 0.045. So these are the decimal places that we're going to add to the 1.6. So 1.6 plus this value is going to give us 1.645. And finally, this can be positive or negative. Okay. Very good. So now that we have this, let's write it down. So we have 1.645 on the right hand side and minus 1.645 on the left hand side. Excellent. So all that's left to do now is to find the Z value using this main formula that you can see on the side. Okay, so let's write down what we know first. So first we need to find out the first sample proportion. So P1 hat. Now we said before that this is x1 over n1. So x1 in this case would be the 54 finance executives that agree. So 54, and then in total, there's 120 executives in finance. So N1 is 120. This should give you 0.45. And then we do the same thing for P2 hat. P2 hat is 63, which is X2, divided by 180. And this, again, should give you 0.35. Okay. And then we need to find out P hat, so the total sample proportion. The total sample proportion is X1, so 54, plus X2, plus 63, over N1 plus N2, which is 120 plus 180, which is 300, which in total should give you 0.39. Excellent. So now we have pretty much everything we need apart from P1 minus P2. Okay, now this is the trickiest part in this question. Now the good thing is that if we look at the nil hypotheses, we have an equality. This equality is that P1 is equal to P2. Now what we can do is play around with this equality. So let's see, P1 minus P2, P1 is equal to P2, sorry. So then we can rearrange this formula and say that P1 minus P2 is equal to 0, okay? And as you can see, this is what we need. So P1 minus P2 is equal to 0. And we get this simply by rearranging this equality. Excellent. So now we have everything we need. So now we just plug in the values. So the Z value is P1 hat minus P2 hat, so 0.45 minus 0.35, minus P1 minus P2, which we know is 0, so minus 0, over the square root of the total sample proportion, 0.39, times 1 minus P hat, so 1 minus 0.39, times 1 over N1, which we said N1 is 120, plus 1 over N2, which is 1 over 180, and square root of the whole thing. Now, I've already calculated the answer in order to save some time, but if you plug this into your calculator, you should get that the Z value is 1.74. Now, looking back at our graph, as you can see, 1.74 is past that critical value. So it's inside the rejection region. It's inside the shaded region or rejection region. Therefore, this means that we reject the nil hypotheses. Okay? So if we want to put this into words, what this basically means is that there is evidence of a difference of opinion. Looking at the hypotheses, this basically means that the first proportion is not equal to the second proportion. Okay? So that's it for this question. Let me know down in the comments if you have any questions. I'll be happy to answer them.